Hey, Course 1, Lesson 65 is all about that term prime number. What do you remember about the word prime number? Remember anything about that? The prime number is a number that has exactly two factors. Exactly two. Only two. Can't have more. Well, we have to remember what a factor is. A factor is a number that is being multiplied with another number to get to a product. So what are the factors of 3? 1 and 3. What are the factors of 4? Well, a little more complicated. Could be 1 and 4. Could be 2 and 2. Right? Depends. That's all possible factors. Factors are numbers that multiply together. Now, which of my examples, 3 or 4, was prime? 4 had 3 factors, so that's what we call a composite number, whereas, 4 had, if I said that wrong, I don't know. 4 had 3 factors, therefore 4 is a composite number. More than 2 factors. But 3 was prime because it only had the factors 1 and 3. And we're going to learn what's called prime factorization, which means breaking up the Lego fort of a number into its smallest Legos. Does that make sense? Prime factorization shows a number like 8 as, so we want to prime factorize it. We show it as a product of its smallest pieces. 2 is the smallest numbers we can split it into besides 1. Because if we did 1, then I'd have to show it as 1 times 8, and 8's a pretty big number. I can divide 8 up more. So we divide it into its prime number Lego blocks, if that makes sense. Composite means all the other numbers, whereas prime means it is exactly 2 factors. The composite number that kind of breaks the rule is 1, because it's got not exactly 2 factors. It's not a good example of either one. But as the book says, every whole number greater than 1 is either prime or composite. Okay, so 1 is kind of its own crazy category. And then all other numbers are either prime or composite. I have here listed at the top 4 numbers that are all considered composite, which means we can split them up. I'm going to use the method called the factor tree. 8 can be split up into, let's say, 4 and 2. We just need to come up with 2 factors to start. I circle if one of the numbers I show is already prime, and you could use your prime number chart if you still have it to remember which numbers are prime. 2 can't be split up into anything else besides 2 and 1, which doesn't help me. That's the furthest I can go with 2. That's a prime number, I stop. But 4 is another composite. So 4 I'm going to split into 2 numbers that don't include 1. Don't use 1 when you're building a factor tree. 4 splits up to 2, which are 2 more prime numbers. And then I list the 3 numbers, least to greatest, that I have circled. 2 times 2 times 2 times 2 is the prime factorization for 8. Now, the book is also going to say use division of primes to find the products, the prime number products. If it ever says division of primes, just ignore it. You can use the way I'm showing you. If you like division of primes, you can learn about that in the book. Otherwise, what I've shown you is what's called the factor tree. Why? Because it kind of looks like a tree when you build it. Kind of looks like a Christmas tree here. They always go from little to bigger at the bottom. They're kind of triangle shaped. And that's the way I'm used to using it. That's the way kids usually like to do it. So I'm okay with you always using that, even if it says division of primes. Let's quick dance through the last 3 here. 21 is a composite number. What are two factors that don't use the factor 1? This is why our times tables are helpful. Math facts. Looks like I've got a prime number. And 7's a kind of bigger one, but it is prime. I can't split it into anything else besides 1 and 7. So how do I show the prime factorization? Least to greatest. 3 times 7 is 21. Right? That's the factor tree that gets me down to the prime factorization. Let's build the factor tree for 48. What are two factors? There's actually multiple factors. I could choose 6 and 8. I could choose 12 and 4. I'm telling you right now, both will get me to the right answer. But why won't I just write 12 times 4 is the answer for 48? Because these can both be broken into smaller amounts. So I don't like that. Let's build the tree quick. Okay? That's the best way to do it. 4 can be split up into 2 and 2, which are both prime. And 12 gets a 2 and a 6. Which one's prime? The 2. Make sure you circle it before you move on. You gotta be neat with this 2. Give yourself space so you don't lose that 2 later. And then another 2 and another 3. I'm going to keep my color. Least to greatest. How many 2's do I have? I've got 4 2's. Notice a lot of times the book will use the dot for multiply for these. Not a bad thing to get used to. And 3. How many circles did I have? 5 circles. 5 factors here. Perfect. So that should end up at 48. How could we check this? Let's type it in a calculator. Let's finish up with 60 as a composite number. Let's break it up into its prime numbers. I like 6 and 10. 2, 3, 2, 5. It only took, what, 3 branches? 1, 2, 3 to get to my answer there. So let's write it as prime factorization. 2 times 2 times 3 times 5 is 60. That's my prime factorization. Okay? Split it up into its smallest primes. Got it? Here's some more examples of factor trees and branches to get to our prime numbers. Letter A, which ones are composite? Meaning which ones have more than 2 factors? Does 19 have more than 2 factors? Can you think of anything besides 1 and 19? I can't. I can test if 19 is divisible by 3 or 9 by adding the 2 digits, 1 and 9. That's 10. Is 10 divisible by 3? Or is 10 divisible by 9? Not evenly. So that's prime, not composite. It's looking for composite. How about 2, 0, 20? Even numbers are always composite because they can always be divided by 2 unless you see the number 2 itself. 2 is prime, of course, but this one's composite. It's got 2, 5, and 2 as its prime number pieces, but its factors are 1, 2, 10, and 20. 21 we just broke up as a composite because of 3 and 7. 22 is another non-2 even number. 23, again, add up the digits, test the divisibility. 5 is not divisible by 3 or 6 or 9. Therefore, 23 is not divisible by those. And 23 is not divisible by anything else either. Write the prime factorization for each composite number. Let's just pick one. How about 22? Factor tree for 22, 2 and 11. And 11 is a big old prime number, believe it or not. So writing the prime factorization would look like that. Maybe I'll show it equaling 22. That's the answer for B. I'll let you represent letter C to show the prime factorization of 36. Let's not do D. And E is a big one you can do for me, please.